Hi, Assalamualaikum. Today I want to present an EOC of course DEE 20023 Semiconductor Device. My name is Muhammad Haziq Ramadhan bin Zamri. My student ID is 09DEP20F1025 and my class is DEP2C December 2020. The topic given to me is describe the following rectifier circuit. A. Half wave, B. Full wave, and C. Bridge rectifier. Diode in rectifier circuit. A conversion of alternating current AC into direct current DC is called rectification. A diode is well suited for this job because it only conducts when forward bias. There have three types of rectifiers: half wave, full wave, and bridge rectifiers. The first one is half wave rectifiers. An AC voltage is applied to a single diode connected in series with a load resistor RL. The schematic diagram shown one diode and one load resistor RL connect with a series circuit. Circuit operation for the half wave is during the positive half cycle of input AC voltage. When M is positive, the diode is forward biased and conducts. While conducting, diode act as a short circuit, so the circuit current flows. The output waveform is similar to the input voltage waveform. Vin equal to Vout. During AC voltage, when point M become negative, the diode reverse bias, so off, so it does not conduct current. Diode act as an open circuit, so there is no current flow. There is no voltage drop across RL. The negative input half cycle is suppressed. Now the second one is a full wave rectifiers. The full wave rectifier circuit using two diode and a center tap transformer, which usually taken as the ground or zero voltage reference point. The purpose of center tap transformer is to get two AC output with the same value but in inverse phase. In the schematic diagram shown two diode and one transformer, which is the center tap of transformer and connect to the load resistor. Circuit operation of a full wave is when input AC supply is switched on, the N, M, and N of the transformer secondary became positive and negative alternately. When terminal M is positive, the G is at zero potential and N at negative potential. Diode known as D1 is in forward bias and diode D2 is in reverse bias. As a result, the positive half cycle of the voltage appear across RL. Next, when the terminal N is positive, G is at zero potential and M is at negative potential. Diode D2 is in forward bias and diode D1 is in reverse bias. As a result, positive half cycle of the voltage appear across RL. The last one is a bridge rectifier. A bridge rectifier require 4 diodes, but the transformer used did not center tap and has a maximum voltage across its secondary. The schematic circuit shown have 4 diodes, one transformer, and load resistor. But this one is not center tap. How the bridge rectifier circuit operation is when terminal M of the secondary is positive and N is negative. Diode D1 and D2 become forward bias. When diode D3 and D4 become reverse bias, a current flow along M to E to D1 to A to resistor load to load resistor to B to C to diode 2 to F and to N. Produce a positive half wave waveform across RN. when terminal N of the secondary is positive and M is negative, diode D3 and D4 become forward bias, while when diode D1 and D2 become reverse bias. A current flow along N to F to D4 to A to RL to B to C to diode 3 to E and to M. This produces a positive half-wave waveform across RL. So the last page is the comparison between half-wave rectifier, full-wave rectifier, and bridge rectifier.